Alright guys, so today we're going to be going over quick sort. We're going to do a couple things. First, I'm just going to give you a really quick overview, very simple, very high level over how quick sort works. From then, we're going to move on to doing and showing how the implementation of it works on an actual array. Here, we're just going to kind of move things around just for simple explanation. I'm going to show you how it would work in place within an array. We're going to go over the description of the algorithm just in basic plain English. And at the end, we'll finally go over the code on Python following along with the array implementation, right? So the goal of this explanation of this video is to give you a very clear, very high level understanding of the algorithm first. This is taken from the Introduction to Algorithms textbook. If you've never gotten an algorithms textbook and maybe you're looking for one, I do recommend it. It's the one we used in my class, and to this day I still reference it. But again, my goal for this video is that you get a very clear understanding of this algorithm, and that once you see the code, you'll be able to implement it with confidence. And from that point on, you'll have that algorithm in the back of your pocket. You'll feel confident when explaining it in a tech interview, or for homework, or explaining it to someone else. So that's the goal for this, and so we'll get right to it, right? So okay, the main thing you have to remember with quicksort, right? There's one thing you should worry about, and I have a couple things colored here just for future reference, but the only thing you need to really care about is what we call the pivot element. So this element, in this case, for this example of quicksort, we're just going to select the last element on the list. So for this case, we have the 4, right? All we care about for any other number in this list is if it's a lower quantity or higher than the 4, right? And as we go through the rest of these numbers, you'll be able to. That's all we really care about, because at the end of the day, what quicksort does is it makes sure that your pivot element is in the right location in reference to everything else, right? We're not gonna worry about the rest of them other than is it lower or is it higher, right? So we start at the beginning of the list. We have a 6 here. This is higher, so we're going to put it on this high end. We're going to look at the 5, our current number. Is this higher or lower than the 4? This is higher, so we'll put it here. We're going to scoot one more. Look at the 3, that's lower than the 4. We're going to put it in the low list. Go to the 1, is this higher or lower? This is lower, so we're going to put it here. Look at the 8, higher or lower than the 4? This is higher, we're going to put it on the right side of it. Look at the 7, is this higher or lower than the 4? Higher again, so we'll put it there. And last, we'll look at the 2. Is this higher or lower than the 4? This is lower, so we'll put it on the left. So now, these numbers on the low side, they're not necessarily in order. These numbers on the right side of this barrier that we have here, so the high list, is not necessarily in order. But we do know that the 4, because of the way we kind of like went through the list, we know that the 4 being between these two sets is always higher than any number on this list, and we know that it's always lower than any number on the high list, right? So in that sense, the 4 is in the right position, right, relative to the left and the right side. So the way quicksort works from this point on is, now that we know that our pivot element is in the right place, we're going to continue sorting these other two lists, but we're going to do that separately. So now we're going to call the quicksort function, or rather, we're just going to worry about these sets of numbers, right? So again, just like we had our list here earlier, and we're trying to sort all these numbers, we're only going to worry about these subset of the smaller list, right? So now, for a pivot element, we're going to select, I guess, the number, again, from this smaller list, we're going to select the last number. In this case, it's going to be the 2. And same thing, we're going to check, is this number bigger or smaller than the 2? 3 is bigger. We're going to put it on the right side. Number 1, is this bigger or smaller than the 2? It's smaller, so we're going to put it on the left side. And the same thing happens, right? Now we have a lower side and a higher side, and we know that anything to the right of the 2 is in its is higher than the 2. Anything lower than the 2 is lower. So regardless of how many elements are in either the low side or the right side, we also have the 2 in its proper place, right? So again, these are still technically smaller lists. So we're gonna again do the same thing, but it'll be very quickly, right? So now we do the same thing with the 1. So the 1 is the pivot element. There's nothing else to check. So the 1 is already in its proper place. Same thing with the 3. Even if as it's checked, it's the only element in the list. So it is a pivot element. So that's in its proper place, right? So when this list gets returned back to the, original list, it's in place here. It's the last element. This one again was the only one. It's the first element in the list. And now we see here that when we return this entire list back to the lower side, we get this in order, right? So while originally this was maybe a list that was jumbled up, that was messy, now we have these elements return in order after they were called multiple times through QuickSort, right? So we do that again with the right side, because remember on the high side, that's still not necessarily in order. We just knew that everything on the right was higher than the 4. So we have this list of disorganized elements. We're going to select the last element as the pivot element. And again, all we want to know is this higher? Is the number higher or lower than the pivot, right? So 6 is lower. We point at 5. 5 is also lower. We look at 8. 8 is higher than 7. So we have a smaller list of 2 here. So we're going to check this one. We select 6 as a pivot element. And again, we check if 5 is lower or higher. We're going to put it low. Same thing's going to happen where we're going to try to sort this list. Again, there's only one element in this list. It's the pivot element. So that's already in order. So we turn that back. And then this was the only element, and it's the only element that came before the pivot element. So 5 and 6 returns to this other list in that order. And again, we had this one higher element. We call to sort it, but it's the only element in the list, which makes it the pivot element. And again, that gets returned back to list in order. So now we have everything that's before the 7, lower than the 7, and this smaller list sorted, and everything that's higher sorted as well. So now we know our number list is in the right order for this higher subset. So this returned to the original QuickSort call. And again, this is kind of how it just it takes it one pivot element at a time. Again, it splits in lower and higher, and for each time it does that, it keeps calling it again and again until the list is just completely sorted, and then it returns it back in that order. So now you see here it came back 1, 2, 3, 4, 5, 6, 7, 8 back to the original QuickSort call, right? Okay, so I think that's the basic explanation for it. And again, just as an overview, it's the main things you have to worry about is the pivot element that you select, which in this case we're just selecting the last element on the list. And for every number that's left on the list, we just want to know if it's higher or lower. And after that, after we create those sublists, we then select the pivot element for those small lists, and so on and so forth, right? So we're going to take a look at how this is implemented in an array, right? Here we were kind of like just moving numbers all over the place, but that was just more for clarity to show all the recursive calls. So again, we have a list. It's not in order. We select the last element from the list as our pivot element, right? So again, we want to know, we're going to create a barrier using like a placement or like an index within our array just like how in our example, everything to the left of, what was clearly buried here was a smaller number. In this same sense, anything at this index level or to the left of it is going to be smaller. So that'll be a little more clearly as we progress through it. So again, we'll kind of do a little quick overview over it, and then we'll go into the actual algorithm explanation here. So we start at the pivot element 4, right? We're going to check the first number on the list, 6. So we check whether 6 is bigger or smaller than the 4. 6 is a bigger number than the 4. So currently we don't have anything that's smaller than the 4. So we just proceed and check the next one. Because again, there's nothing to the left of this index that's smaller because we haven't found that element yet. So 5 is 5, bigger, smaller than the 4. 5 is bigger again, so this would stay on the right side of this barrier that we set up as the index. Now we check 3. 3 is indeed smaller than the 4. So because we now want to include an element that is smaller and want that to be to the left of this index, this smaller element index, we're going to move it 1 up. And because we want everything that's at this location or to the left of it to be smaller, we're then going to swap this position with the current index, right? So we swap the 3 with the 6, and it still stays true that everything at this index or to the left of it is smaller, because so far everything we've checked, which is the 5 and the 6, is bigger. So these are all in the right position. We still haven't checked the rest of this, so we're going to continue with that. So we check, is one is smaller than the pivot, so we want this at this position or to the left of it, but this is the beginning of the array, so we do have to extend this this positioning 1 more, and again we're going to swap it between where the current index is at for the smaller one, so the 1, and whatever was in that position, we're just going to put it back in that place. And as you can see here, it still stays true that everything at this index or to the left of it is smaller than the pivot element. So while here we were just dragging and dropping into the low and high, here we're checking and we're making sure that we're creating a space where everything to the left of this smaller index is actually smaller than that, right? So again, we check the next one, we check 8. If that's smaller or bigger, that's still bigger, so we leave that where it is. We check 7. 7 is bigger, so we leave that where it is. We check 2. 2 is smaller than the pivot, so again we extend the room for this index, and then we're going to swap again. And here we have a list where we have an array where everything to the left of this smaller index indicator is smaller than the 4, and everything to the right of it is bigger. But here we have this issue where the pivot element is out of place at this point. So what we do here at the end of this part, we just extend it 1 more, and then we do another swap with the pivot element and the current number there, right? And the end product we have here is similar to the way we were positioning here, where everything to the left of it was smaller, everything to the right of it was bigger, and now the pivot element is in the right position. And from here, from this point on, we could do the same recursive calls, where now we really just want to check each one of these smaller lists, right? So again, you could take this, and we're going to select our pivot element. It's going to be the last element too. And again, we haven't checked anything on the list, so we don't know what's smaller yet technically. But again, we start with the first number, right? Is 3 smaller or bigger? It's bigger, so we move on. Is 1 smaller or bigger? It is smaller, so we extend the smaller element index, and we swap with whatever was in the current index. So now everything here and to the left is smaller than the 2. Again, here we finished checking and we just have the pivot. So again, we do another, we move the small element index 1 and we switch these again as we did earlier. So now there's only one element left. So as you saw earlier, everything we check, if we check this one, this element is going to be the pivot, and so that's going to be in order. This element is going to be a pivot, so that's in order, and it's going to return back into place, right? So this becomes sorted, right? And when this returns here, it's going to be in place again, right? And same thing for the higher side of it, right? We're gonna pick our pivot element. In this case, the 5. We haven't checked any of the numbers, so we don't know where the smaller index will be since none of the numbers have been checked. We check the 8. The 8 is bigger, so we're gonna leave that there. Check the 7. The 7 is bigger than 5. We're gonna leave that there. We check the 6. The 6 is bigger than the 5, so we leave that there. So because we've checked everything, nothing is small, we haven't moved this smaller element index. We know that this is going to be the smallest one. So again, we just scoot it 1 to the first starting position of the index, and we swap that with the 5. Cool. So from here, we'd have to check this sub list, but we know everything here is already bigger, right? So again, we pick our pivot element, in this case the 8. We're going to check the first number. We check if 7 is bigger than the 8. 7 is smaller, so we're going to move this one forward and we swap it with the current index. This is the same. The current index and the small element index is the same, so it really just stays in that position. Then we're gonna check the 6. The 6 is also smaller, and then so we're gonna move it up, and again we swap the current index with the smaller index, and these are still the same, so the swap just makes the number stay in the same place. And now we check the pivot of the 8. So on this part, when we move it, there's really nothing for it to pivot with, because also at the end of it, we move the smaller index 1 and we switch it. So again, we ended up with everything to the left of it being smaller. So we continue again with this list, right? I think at this point, you more or less kind of get the hang of it, how at the end of all these recursive calls, you are going to get a list that gets organized or sorted in order by splitting it into smaller lists and just putting everything to the left of it in a smaller quantity or a bigger quantity, right? So let's take a look at the instructions. Right, so this is going to be the plain English implementation of the algorithm that we have over here. So let's just get our list unsorted again so we can go over that. Okay, cool. So I'm sure as you've been following along, you've seen some and heard some common elements, right? We have our pivot number, we have the current index of the number we're checking, and we have the smaller element index, which is kind of what sets up the barrier for all those smaller elements, right? At the end of all that, we end up doing the same thing, calling QuickSort, or finding the right place for a new pivot on a new list that's smaller on the low end and the high list, right? So these are this is like plain bare bones English explanation of everything we've been doing, just as we did it over here and just as we did over here in the array. But again, this is going to be kind of what helps you link it between what's happening in the implementation and what's happening within the code itself. And I think the more clear of an understanding you have of the actual instructions of what's going on, the easier it'll be for you to understand and just be able to actually implement the code instead of just trying to focus on cold memorization. To some extent, you're still gonna have to practice to memorize it, but I think the deeper the understanding, the easier that will be. So, okay, let's go through our first step. So first we're going to pick our pivot number. We do that here. We're picking the last element of our unsorted list. So now we move on to partitioning this list into low and high sections. Okay, in the partition function that we're going to perform first, I'm sure you saw the procedure of it. It works as a loop, and in this loop, we check the numbers on the array, starting by checking each number in the current index. So at the beginning of the array, we start with the first number, and then if this number is less than or equal to the pivot, so is 6 less than the pivot? It's not. So then we can skip all this, right? And then we move on to the next one. Again, we're still in this loop. We're checking a number in index. So is the number less than or equal to in the pivot? It's not. So we're going to skip all these two steps within that branch. So we go to 3. So current index is at 3. Is 3 less than the current index? Or is 3 less than the pivot? It is. So what we do is we're going to increase the size of the smaller element index. So smaller element index plus 1. So we move that 1 to the first part. And then we're going to swap the number that's in the current index with the number that's smaller at the small element index. This is what we do, is swap. We move this here and here. So again, like we were saying earlier, everything that's at the smaller element index and to the left of it should be smaller than the pivot. Okay, cool. And that's we perform the swap. Okay, and this is something that happens at the end of the list. So again, we're still with this loop, right, where we're checking each number. So we'll move the current index 1 forward. Is the 1 less than or equal to the pivot? 1 is less. So again, we increase smaller index by 1. So we move it up 1. And then we swap the current index with the smaller index. So again, we do another swap. Okay, cool. And then we check everything 2 at this position and to the left of it is smaller than the 4. So now we move forward 1 on the current index. Is this smaller than the pivot? Smaller than or equal to the pivot? It's not. So again, we don't do any swaps. We check again. This is still bigger than the index. And then last, the 2. The 2 is smaller than the index. So again, we increase the smaller element index plus 1. And we swap the position of the element at the current index with the element at smaller index. So another swap. All right, nice. So current index is equal to the pivot. So this is that last step that we have here. So we're gonna again increase the small element index by 1. And we're gonna perform another swap. So what we have now, again, is that first pivot element has been placed in the correct order relative to everything to the left of it being lower, everything to the right of it being higher. And after you do this first partitioning, what you go ahead and do is you do the rest of your recursive calls, right? So now we're going to call QuickSort, but instead of giving it the whole array, we're going to give it the section to the left of the pivot. So everything from this part to this part, right? And then your other QuickSort call is going to be everything to the right of it. So that's why we have this QuickSort low and QuickSort high. And I'm sure if you recall here on this section, as we did each low side and each high side, from each smaller list we would find a new pivot, also find the lower elements and the higher elements, and so on and so forth. So this is the section of the algorithm where you get all those recursive calls to make the list smaller and smaller. And as you make the list smaller, you also sort it. It becomes more sorted over time with each iteration, right? So that's the plain English. That's a plain English explanation of the steps that the algorithm takes in order to use QuickSort and get everything in order. So now I think it'd be a good time to move into the actual code of it, right? So this is going to be in Python 3. I think the easier the programming language you use, the easier it'll be for you to memorize, whatever you want to do with that. So let's get Let's get our sorted list one more time, get it unsorted. And I think this is where it really comes together, and hopefully this ends up being the last tutorial you end up watching for QuickSort. So let's get that started one more time. All right, so when we start looking at the code, let's give it a quick overview at some of the main things that are happening on it, right? So as you can see here, we have two functions. We have your QuickSort function and we have your partition function, right? So starting out the QuickSort function, you do see here at the core of it, you are calling the partition function once, and then the partition function takes the same array that the QuickSort function takes, the same start index, the same end index, so the starting position of the array and the ending position. And then it calls the partition function on those, the beginning and end, and it returns the pivot index, right? So this is going to return the position of the number in the list that is in its sorted position, and everything to the left of it should be already not sorted, but should be less than the index itself. Everything to the right of it should be higher. And we know that that's what it expects, because when you look at the QuickSort function right below it, the two recursive ones right below it, it takes the same array and goes from the starting index of the original array to the first position at the left of the pivot index, and the second one takes everything at the right of the pivot index to the end of it, right? So this is where it calls everything to the left and to the right of the original array. So we know here that the main thing to understand about quick sorting is the partition function, right? So again, starting from the QuickSort function itself, it takes an array list, it takes a starting index, it takes an ending index, right? And the first thing it checks is it just checks if the starting index is less than the ending index, and that's just to see if the list is greater than the size of 1. As you remember, for each recursive call that we do here, as we go down on each small list, it does end up becoming, a size of 1. So that's what that first check is, right? So we're starting with this. That's not the case here, because we're starting with this index. We're starting with this array. It's not organized and it's greater than 1. So we move on to figuring out the pivot index by calling the partition function on this array, right? So it's going to take this array. It takes the starting position, which is index of 0, and the ending position, so the last element here. And on the partition function itself here, we see that it sets the pivot value to the last element of the array. So that's going to be our 4 here. So we know our pivot value is equal to 4. Then we see that our smaller element index, this is going to be the starting index minus 1. So it has not yet found a position for anything smaller than the pivot. So it starts out, it doesn't have a position in the array technically right now, right? So we have our pivot, we have our smaller index, and then our smaller element index. So now we're going to start the loop where we take our current index, starting from the start index to the end. That's our error right here. And we're going to do the checks for the size, comparing them to the pivot value, right? So if the element at current index is less than or equal to the pivot value, so if 6 is less than or equal to 4, then that's where we do the movement and the swap, but 6 is not bigger, so we don't worry about this if statement. We move it 1 up. We check if 5 is less than 4. It's not, so we move 1 more up. So here we have a valid iteration for this branch. So 3 is less than the pivot element. So because we have that as a smaller element, we go to inside this branch. So we're going to move the smaller element index 1 space. So this will move it 1, right? And then we're going to do the swap. So the way the swap is written here is we take the element at the smaller element index and the element at the current index, and we reverse those, right? We're going to set it equal so that now smaller element index is equal to the current element index, and vice versa. The current element index is now going to be the smaller element index. So this is the line for the swap. Again, they're just going to switch the values and the positions that they have at the moment. Same thing, right? The loop continues. We check one is less than pivot. Again, we add 1 to the position of the smaller element index. We perform a swap for these two values. And again, we see that pattern again where everything at the position of this index and to the left of it is less than the pivot. We continue. This is not less, so we move one more. This is still more than the 4, so we move one more. Again, this is less than the pivot value, so we're going to move the element index one position. We're going to perform a swap for the values. And again, everything to the left of here at this position to the left of it is less than or equal to 4. And then we go one more. Well, we're at the end of the index, right? Because this is not inclusive. So the final pivot index, it takes the smaller element index and it adds 1. So we move it forward, and now we're going to switch the position 2 of the final pivot index, which is this one, and the position of the last index, which is this one, the one pivot, and that's where we do a swap. So now this is in the right position relative to everything to the right is higher than the 4. Everything to the left is smaller. And what we return is not the 4 itself, but we return the number element for this position in the array. So the pivot index now returns this. So the pivot index integer that called the partition function here now has the value for this position. And because we know now that this position will be in order, now we want to call the QuickSort function on everything to the left of it, which is everything here. So now this is going to call the array from the starting position of the original array, which is 0, to everything to the left of this pivot index, right? So it's going to be pivot index minus 1. So everything that's going to be called again is going to be from this starting position to this starting position on the second QuickSort call. Again, and everything to the right of it is going to be also called, as you can see here. So starting from takes the original array, takes the pivot index plus 1. So this was the pivot index position plus 1. So starting from here to the end of it. And again, it performs QuickSort recursively by taking this smaller array that it's going to call QuickSort on. And on this array itself, it's also going to perform the same functions where the same steps are where it takes the pivot element, it takes the smaller element index, and it goes through all the numbers one by one, checking if they're smaller or bigger than the pivot and switching their position accordingly until the list becomes completely sorted by reducing the sizes, one recursive call at a time, right? So that's basically the code. And I think once you get a good view of the code compared to just the plain English explanation, you do get a bit of a clearer understanding of how QuickSort works. And despite the complexity of, I think at first it can be a little intimidating to see the code without really understanding how it progresses. So that's why I think reading the textbook can be helpful. But I think at the core, all QuickSort is picking one element and sorting everything to the left of it as lower and to the right of it as higher. Now, there is some abstractness that comes from understanding recursive calls. So I think if the concept of recursive calls was a little bit troubling, confusing, or just hard to understand, that's definitely one of the key and core principles that comes to understanding this kind of algorithm or any algorithm moving forward. So that's something that you felt a little bit stuck on or a little bit lost on. I would recommend reviewing it a little more. But I do thank you guys for watching this. I hope this was helpful for you. I hope this hopefully it's the last video you have to watch on the implementation of QuickSort, and hopefully you do great on all your tech interviews. So any suggestions and feedback, please comment them below. I do have a Discord channel where I'm going to be helping people out with their tech interviews, with things that they want to learn in tech, whether you have no experience programming at all. I know this is a little more advanced, or just anything tech industry related, really. So any questions, any messages, put a comment below, join my Discord, and see you all in the next one.